I want you guys to have the best education you can. So here we go, guys. The composite argument property cosine A minus B. We're going to derive the formula. You guys ready? So we're going to start on the right-hand side. Draw quadrant 1 of the unit circle. If you have colored pencils, it is a good place to have colored pencils. And we're going to make it big. That's fine. Colored pens, colored pencils. And here is quadrant 1 of the unit circle. I actually did a good job there, probably the best one. And then I'm going to draw angle A. So here's angle A. And because that's angle A, I can rewrite this coordinate instead of xy. I can rewrite this as cosine A, comma, sine A. Are we okay with that terminology there? Okay. And now I'm going to write ray B here, or angle B. And I'm going to, so in blue, I'm going to do it in blue. I'm going to call this angle B. And what we're trying to derive is a formula. Well, first, let me put the ordered pair here. Cosine B, sine B. That's my x and y coordinate. And this in green is A minus B. Right? Because the angle A and you subtract angle B, and that difference is A minus B. Are we still okay? All right, in geometry, and it's okay, let's not blame anyone. In geometry, you found distances of chords, and if you didn't do that, it's fine, no big deal. We're going to call that distance D. So do you guys see that distance there? It's a straight line, and I'm just going to find the distance of that chord there. You can also call it a secant. Doesn't necessarily have to be a chord. And hopefully you remember. The distance formula is related to Pythagorean theorem. It's just a change in x squared plus a change in y squared. And in case you're wondering, Travis, how did you get that formula? Well, look, there's like a triangle right there. So it's like a squared plus b squared equals, well, I guess in that case, d squared, if I call that d. Do you guys see that? All right, so here we go. On the left-hand side, I'm going to find the distance d. And we're going to call it d squared, guys. So I'm going to zoom out temporarily because I'm probably going to use the whole distance. Why am I calling it d squared? Because I don't want to have that square root there. So d squared, and let me color code this part so you guys can know what I'm doing. What color do you think? What color is this? Is this like purple or lilac or something? Lavender? Okay. So this is what you call horizontal displacement. If you had physics, you've already done this. So I just want that value, that lavender value. So that's just a change in x. I'm gonna write cosine B first. Cosine B minus cosine A. Close it squared. Is everyone okay with how I got that? And I'm gonna have a plus, and I'm trying to color code everything here, guys, for you guys. Plus. And then I'm going to do, let's see, the vertical displacement. So I'm going to go this color. What color is this? Light blue, sky blue? Okay, so sky blue. So I just want that vertical displacement. So sine A minus sine B. Close it squared. Is everyone okay with what I am doing? No one's lost. All I did was Pythagorean theorem or distance formula. Travis, why isn't the square root there? Because I put a squared there. So square, that takes away the square root. Okay, now you're done with pre-cal. We're just going to expand it. So I'm going to go back to my neutral color. I'm going to use black. So I'm going to go d squared equals cosine B times cosine B. What's that? Yeah, say the squared first before the b. Because if you say cosine b squared, it sounds like the argument is squared. You want cosine to be squared, so you say it cosine squared b. Cool? And then cosine b times cosine a, that is Cosine B, cosine A. Usually you want to say things in alphabetical order, so cosine A, cosine B. And you're going to have how many of those? So I'm going to write minus 2 cosine A, cosine B. And then negative cosine A times a negative cosine A, that is a... Perfect. I have no idea why, but the song We Don't Talk About Bruno's in my head right now. We don't talk about Bruno. It's so catchy. It's so catchy. Maybe we can make something about pre-cal. We don't talk about you. No, I'll stop. That was lame. I just annoyed myself, guys. So let's just stick to this. All right. Sine A times sine A. What's that? So I'm going to write sine squared A. And then sine A times negative sine B. That's going to be sine A sine B, negative, of course. How many of them are going to have? So minus 2 sine A sine B. And then finally, sine B times sine B. Sine squared B, perfect. So you're done there, pretty much. Now we're just going to, and I'll zoom in a little bit, guys. We're going to combine stuff. Chavez, what do you mean? Well, I have a cosine squared B here, and I have a sine squared B here. Those two together, Valentine's is coming up, those two together are what? 1. So I'm going to write d squared equals, and then check it out. Look at this one right here. Cosine squared A plus sine squared A. That's also 1. What's 1 plus 1? 2. So we're going to write 2 minus 2 cosine A cosine B minus 2 sine A sine B. And we're going to keep it for now. This is the formula that we want. Don't worry, we're going to connect it in a little bit. Let me zoom in so you guys can see. How do we feel? Okay, so let me tell you the game plan that we're going to do. We're going to try. So do you guys see this unit circle? Here's the game plan. Ouch. So what we're going to do, we're going to slide this, that blue line is going to be right on top of the x-axis. So we're going to slide it where that's right on top of the x-axis, and all you're going to see is that green curve like that and that red line on the top. Does that make sense to you guys? Okay, so I'm going to draw another one. Same, it's supposed to be the same. I'm trying to draw the same thing. So I'm going to draw it for the sake of transparency so it can be nice and symmetric. I'm going to put it on the left-hand side. So here we go. Right here on the left-hand side, I'm going to go boom. And then the blue line is this one. And I'm going to keep the colors the same so we can know that it's the same. And then my red line is this one up here. That's not red. Red. And then here's my green. A minus B. And this is still, it's not to scale because that one looks smaller and this one looks bigger. That's still D. And this coordinate up here, let me put it in red here. It's no longer cosine A sine A. It's going to be, let's put it in green. Cosine A minus B, comma, sine of A minus B, close, close. And here's how I look so far. And this coordinate way down here, because it is a unit circle, that coordinate way down there is 1, 0. So catch up to there. It's not as cool as my first circle. I feel like both circles are, yeah, this one's way bigger. I was supposed to draw it the same. I know there's a copy paste feature that I could have done because this is digital. So maybe next time. I'm doing the same thing, guys. So I'm going to find this arc, this D is the same as this D. These are the same. Same. It's the same. Are we okay? All right, so we're going to do the same thing again, distance formula. So I'm going to go, let's see, yeah, we got plenty of space. D squared equals, and I'll color code it as well, same color scheme, whatever that color is here, lavender. So let's see, 1 minus cosine of A minus B, close, close, squared. plus, and then what color did I choose? Light sky blue. Sky blue, so there we go. I'm going to write sine of a minus b, close it, minus 0, close it, squared. So catch up to there, guys. Let me put my right little angle on that triangle there. Right angle. Everyone okay so far? Okay. All we're going to do is expand it. So let's see. D squared equals, what's 1 times 1? 1. 1 times cosine A minus B is just cosine A minus B, but I'm going to have how many of those? So minus 2 cosine of A minus B, close it. And then cosine A minus B times cosine A minus B. Perfect. Cosine squared A minus B. And then finally, sine A minus B minus 0 is just sine A minus B. We're just going to square it. Plus sine squared A minus B. So hopefully you're, and I'll slow down because I can see some of you guys trying to catch up. So let me zoom in. Hopefully you can see this. Cosine squared of A minus B plus sine squared of A minus B is equal to, not everyone at the same time, it's equal to 1. So then we're going to have this, guys. I'm going to write it down here. D squared is equal to 1 plus 1 is 2. So 2 minus 2 cosine A minus B. And this is what I wanted. We are so close to getting the answer, guys. So close. All right, look how awesome this is. Remember that we were trying to find what cosine A minus B is. Well, I have a cosine A minus B right here. And remember, these D squares are the same. This one up here in that box is the same as this one. So because they're equivalent, I can just set them equal to each other. So look how beautiful this is going to be. This is why math is so beautiful. 2 minus 2 cosine of A minus B. That's this expression that we got. Equals, and I'm going to set it equal to this expression right here. 2 minus 2 cosine. So 2 minus 2 cosine A cosine B. Was it another minus after that? Yeah. Minus 2 sine A sine B. So let me zoom in for you guys. So get up to there. Are we okay so far? I'm going to subtract 2. This 2 right here. So I'm going to go minus 2, minus 2. So those are going to zero out, and now you're going to have this. Negative 2 cosine A minus B equals negative 2 cosine A cosine B minus 2 sine A sine B. And I left some space in the upper half of your second page. So here's where you should be right now. Are we still okay, guys? Now look at this. Last step. I need to get rid of that negative 2 in front of the cosine A minus B. What do I got to do? Yeah. Perfect. Divide by negative 2. Negative divided by negative is a positive. So here we go. We're going to have cosine of A minus B is equal to, again, negative divided by negative is a positive. Those cancel out. Cosine A cosine B cancel out. Negative divided by negative is a positive, so it turns to a plus. Sine A sine B. And if we did it correctly, this should be the same as the composite argument property that they have in the rectangle down here. And there it is, guys. It's the same. Isn't that cool? Yes, miss. Nah. Oh, that would be so cool. Yeah. More up. More? Now, for those of you that are going to go on to Cal 1 and Cal 2, there's a course, Cal 2, that is super heavy with trig identities. This is all trig identities, trig properties. Cal 1 is not heavy with trig properties, but Cal 2 is. So if you're going to be successful in Cal 2, make sure you are super beast at trig properties. All right, we're going to show you how to use it. You're going to need a calculator. So let me get my calculator out. Oh, no wonder it's off. This one's in degree mode, so let me make sure that my calculator is in degree mode as well. Smart View. Come on, buddy. Yeah, mine's in degree mode. The very first question's in the degree. Eventually, we'll do it all in radians, but we're not there yet. So here's how you use it, guys. It's very basic. Express 7 cosine theta minus 23 is the linear combination of cosine and sine. So in case you don't know what all that means is they want to see an equation. So what does that mean? They want to see, what letter did they use last time? B and C? B cosine theta plus C sine theta. This is what they want to see, where B and C are constants. I just used B and C because I think that's what we used last time. I'm talking about like last week when we had a linear combination. B cosine plus C sine. Okay, so right now I just have a single cosine with a phase displacement, which hopefully you remembered we did that last week where we had two signals, a cosine and a sine, and we turned it to a single cosine with a phase displacement. It's going to come back. We have a few practice problems. Plus there's one in here. So now we're doing the opposite, guys. We want from this one single cosine with a phase displacement, we want to see cosine and sine. So I'm going to write 7, and I'm going to put giant parenthesis, cosine, giant parenthesis again, theta minus 23 degrees, close, close. That theta right here is like A. That 23 degrees is like B, capital B, like the cosine A minus B. You guys know what I'm talking about? Yeah, the formula, the one that we just did. So here we go. I'm going to write 7, giant parenthesis, and now I'm going to expand it. Cosine theta, cosine 23 degrees. All I'm doing is using this formula right here, guys. Plus sine theta, sine 23 degrees. I'm just using the formula. Is everyone okay? And I'm going to distribute that 7. When you distribute the 7, guys, I'm going to put the cosine 23 in the front. Why? Because cosine 23 is a number. Like it's a value, right? And then cosine theta plus 7 sine 23 degrees sine theta. And if you want perfect, you probably want to leave it like that. But if they want to know what that number is, go ahead and type 7 cos 23 and 7 sine 23 in the calculator. Yeah, look, 7 cos 23. Make sure you're in degree mode. Enter. Oh, that's 7 cos 23. I typed an extra number. 6.4435. The more digits, the better. 6.4435 cosine theta plus 7 sine 23. 7 sine 23. Enter. 2.7351. 2.7351. 2.7351 sine theta. And there it is, guys. That's it. And they're supposed to be equivalent. So let's find out if they really are equivalent. Well, yeah, they're not going to be perfect because these decimals go on forever. But in a graph, it's going to look like they're perfect. But if you were to look at a table, maybe 4, 5, 6 digits in, they might be a little off. So here we go. Let's see if they're perfect, guys. So on my you don't have to do this. I'm just doing it real quick. On my calculator here, what was the original equation? 7 cosine x. So there it is. There's my original. And what was the equation that I got? The second one, the new one. 6.4435 cosine x plus 7.351 sine. Okay, they're going to be off a little bit. If I wanted it perfect, I would have put 7 cosine 23, 7 sine 23. But no big deal. Window, I'm in degrees mode, so negative 360 to 260, or 360, sorry. X scale, 90. Y min, you can go negative 10 and 10 because the amplitude is 7, right? And that's good enough. And check it out, graph. So there's my blue, and look, that red one overlays right over it. Now, if I were to look at a table, maybe it's off a little bit. Let's see. It's off a little bit. You can see. Look at the number 2, 6.5351, 6.535. But as you can see by the graph, oh yeah, it's off. You can see there. See? It's off because the decimal keeps going forever, guys. But as you can see by the graph, is it a pretty good, yeah, pretty cool. All right, let's keep going. Now, here's a warm-up. I should have given you guys this question last week. My apologies, guys. I think we could have handled it, but for whatever reason, I didn't put it in there. So when you have a linear combination like this was very popular on an SAT level 2. I don't think they do it anymore. I think they still do it. They still use equations like this for entrance exams. And you will see questions like this on the UH math contest that's coming up this Saturday. So when you get this question on this Saturday, it'll be something that is a perfect radian. This we need a calculator. Do you know how to do it? Say yes. Yeah. Remember that last week we were able to do this right here that I'm circling into a single cosine with a phase displacement? So let's do that. My amplitude, negative 2 squared plus 3 squared and the square root of that. In case you're wondering what I'm doing this. Negative 2, 3 point, and the amplitude was this distance here. And then this was the phase displacement, d. Do you guys remember that? So here we go. 2 squared is 4, 3 squared is 9, 9 plus 4 is 13, so the square root of 13, leave it alone. The phase displacement. Arctan of 3 over negative 2, it's going to give me an answer in quadrant 4, so I'm going to add pi, and I'm in radian mode. So I'm going to switch my calculator to radian. So here's my calculator. Don't worry, guys. I'll put all the work in here. Mode, radian, enter, second quit, and then what was I going to do? Arctan. Arctan of 3 divided by negative 2. And notice that it gives you an answer in quadrant 4. Chavez, how do you know it's quadrant 4? Because it says negative. So, and if in case you're wondering, pi divided by 2, 3.14 divided by 2 is like 1.57. So I know between 0 and negative 1.57, that's quadrant 4. That makes sense to you guys? Okay, so I'm going to add pi plus pi. There it is, 2.1587. Yeah, that's quadrant 2, because quadrant 2 is between 1.57 and 3.14. You guys remember? You guys know what I'm talking about? Okay, so that's quadrant 2 for sure. 2.15879893. The more digits, the better. Let's put all of them. I already forgot it. 1587989. Did I get it correct? 3. Okay, so here we go. My equation. Square root of 13, cosine, parenthesis, x minus 2.15879893, close it, equals 2. Now we're just going to solve for x, just like we did the first semester. So on UH, they'll give you something that's a perfect. This one, we need a calculator. So what is the first thing you got to do? Divide by what? Yeah, square root of 13. Whatever you do to one side, do to the other. Leave it alone. So now I have cosine x minus 2.15879893 equals 2 over square root of 13. What's my next step? Inverse cosine. So x minus 2.15879893 equals plus or minus our cosine of 2 over square root of 13 plus 2 pi n, because it repeats every 2 pi. And then last, move the negative 2.1587 right there in front of the plus minus. X equals 2.15879893 plus minus our cosine of 2 over square root of 13 plus 2 pi n. From there, we get 2 equations, guys. And don't worry, I'll slow down. From there, we get 2 equations. I'm going to take the 2.1587 and I'm going to add arc cosine. And I'm going to take the 2.1587 and I'm going to subtract the arc cosine. So I'm just going to go to my calculator. There's the 2.18587, blah, blah, blah. Push enter. Plus second arc cosine. And I already forgot what it was. What was it? 2 over square root of 13? 2 over square root of 13. Make sure you're in radian mode. You are. Enter. And I got 3.1. Oh, that looks like pi. 3.1415926. Yeah, that's pi. I'm going to put 3.1415 for now. Plus 2 pi n. We'll put it here that's pi for sure. X2. X2 is the same thing, but instead of plus, we're going to do what? Minus. So I just recall the equation back. This is why TI calculators are so awesome, because you can just scroll up. Minus, enter. And 1.1760. That also feels like it's a perfect one. 1.1760 plus 2 pi n. They want all my answers. So what's my domain on this question? Okay, negative 2 pi to 2 pi. So one answer is 3.1415. Another answer is 1.1760. You're not going to add 2 pi to pi because then you'll be above. But you can subtract 2 pi from pi. So pi minus 2 pi, that's negative pi. So another answer is negative 3.1415. And then 1.176 minus 2 pi. So let's do that. There's my 1.76 minus 2 pi. And let's push enter. And look at that, negative 5.107. 107.18. Negative 5.107. Was it 18? 18. 107.18. Yep. Cool or not cool? I think these are cool. Let's verify that though. Let's verify that. Verify solution graphically. So check it out, guys. I'm going to type this in. And I'm not going to use this formula. And I bet you we're going to get those same answers. And I hope that you guys are happy with this. So I'm going to go to y equals. I'm going to type in the original equation, which I already forgot. What was it, guys? No, the original. Negative 2, I think. Okay, yeah, that one's way easier to write. Plus 3 sine x. So there it is, and it equals 2, so I type in 2. Now here's how you fix your domain, guys, or your window. Click on window. Your x min is negative 2 pi, because that's what it says in there. So negative 2 pi. And then your x max is 2 pi, so you just put 2 pi. Now if you're wondering, like, oh, what should I make my, I'm going to make the x go 1. What should I make my amplitude or what? Like my y min, y max. Well, my amplitude was square root of 13, which is a number like between 3 and 4. So we can go like 7 to 7 or 8 to 8 or negative 8 to 8. Sorry. Negative 8 to 8. And push graph. And there's my graph. And now look, let's find those 4 intersections. So let's see if they're perfect. They better be perfect. Second, calculate number 5. Enter 1, 2. And I want to get the way back here first. Enter. Did we get negative 5.10718? There we go. We got it. Second, calculate number 5 again. Enter, enter. Then we're going to get this one here. That better be negative pi. Enter. And there it is, negative 3.1415. Isn't that cool? So for sure, this one's going to be pi. That one right here should be 1.1, whatever. So let's see, let's test that one. Second, calculate, number 5. Don't worry, guys, we're almost done. Enter, enter. And go all the way to that one. And enter. 1.1760052. Yeah, cool stuff, right, guys? So when you become an engineer, this is what you're going to be doing. You're going to be doing signal analysis and all that good stuff. Same thing if you go to medical school. What do you think, like, if you went, like, vision? Those are light waves. Those are all cosine and sine.
Not correct because of that. Correct because I was, like, really confused. So I got a completely different number, but then I realized I didn't put my calculator.
Oh, you're good, miss. You're good. All right, last one. This one's going to be very easy for you guys. I try to make my notes where we start off like, bam, like in your face, and then like it gets easier. That's how I try to make it because I know we get tired. So hopefully this question here is easy for you guys. So it says, express 7 cosine 2 theta minus 120 degrees as a linear combination of cosine and sine. So look how easy it is. Again, we just learned this. That 2 theta is like an A. That 120 degrees is like a B. So I'm going to write 7, giant parenthesis, cosine, open another parenthesis, 2 theta minus 120 degrees, close, close. So here we go, 7, giant parenthesis. I'm going to remember, how does this one look? Cosine, cosine, plus sine, sine. It's cosine B, plus sine A, sine B. So here we go. Cosine 2 theta, cosine 120 degrees, put a degree symbol if it's a degree, plus sine 2 theta, sine 120 degrees, close. Are we okay so far, guys? Distribute the 7. And I'm going to write the cosine 120 first after I write the 7. 7 cosine 120 degrees. Why am I doing that? Because cosine of 120 is an actual number. Cosine 2 theta is just an expression in terms of theta. Plus 7 sine 120 degrees, sine 2 theta. And now here we go. Final step. 7 parentheses. What is cosine of 120 degrees? Oh, man. We're going to have to bring the unit circle quizzes back.
It's 1 over 2.
Cosine. Negative 1/2. No, you're good, miss. You're good. Plus 7, and then sine of 120. Square root of 3 over 2. Sine 2 theta. Don't leave it like that. I would prefer you combine it. So 7 times negative half, leave it as 7/2. Yes, you can write it as a decimal if you want. Negative 3.5. Plus, and then 7 square root of 3 over 2, sine 2 theta. This is a preferred way because it's the exact answer, right? And there it is, guys. And that is the exact expression as this guy. If you were to graph them both, it'd be the same curve. And if I were to graph this one, it would be the exact curve because we're not rounding. Those are exact numbers. How do we feel? All right, so we just have an activity. It's over this stuff. It should be pretty basic for you guys, and that's it. So let me stop here, and you guys are good.